Welcome back, Math Masters. A new scroll has arrived at the dojo gates. Today, you'll begin training to earn the Adding and Subtracting Mixed Numbers badge. Solve each problem. Record your answers in simplest form. 3 1/2 plus 2 7/10. 6 1/4 minus 3 5/8. Study well. The path to mastery begins now.
Welcome back, Math Masters. These are bigger numbers than the ones we worked with in our last lesson. I have a feeling we'll need all the fraction skills we've been building to conquer today's challenge. Have your guided notes ready? Training starts now. Smart thinking, Mia. Warm-up stretches are just what we need. But wait, these are the same problems from our last lesson. Oh, never mind. Now it's 3 4/7 plus 5 2/7. Oh, and we also have 7 8/9 minus 4 3/9. Think about how we worked with adding and subtracting fractions in our last lesson. These already have common denominators, so pause here to solve both problems in your guided notes. When working with mixed numbers, we have both whole numbers and fractional parts. 3 plus 5 equals 8, and 4/7 plus 2/7 equals 6/7, for a total sum of 8 6/7. Then 7 minus 4 equals 3, and 8/9 minus 3/9 equals 5/9, for a difference of 3 5/9. All warmed up, let's get training. All right, 6 4/5 plus 2 3/5. What do you notice about the denominators? They're the same, so we can solve right away. 6 plus 2 equals 8, and 4/5 plus 3/5 equals 7/5. 8 7/5? Remember, a mixed number is a whole number and a proper fraction. Let's convert 7/5 to a mixed number. Then, think about how we could regroup our answer so it's a whole number and a proper fraction. Pause here to give it a try. Seven-fifths converts to the mixed number 1 2/5. Since we already have 8 wholes, we can regroup the extra 1 with those 8 for a total of 9 2/5. Is that in simplest form? Yep, 2 and 5 only share 1 as a common factor. Hey, a training tip! When adding mixed numbers, if your answer has an improper fraction, convert it to a mixed number and regroup the answer as a proper mixed number. Perfect! Next up, 5 7/12 minus 2 1/4. What do we need to do before we can solve? Find a common denominator. That's because the pieces must be the same size before combining or taking away. Fortunately, 12 is a multiple of 4, so we only need to rewrite 1/4. Since 4 times 3 equals 12, we also need to multiply our numerator by 3. That means 1/4 is equivalent to 3/12. And now we can subtract because our denominators are the same. Pause to solve in your guided notes. Remember to record your answer in simplest form. 5 minus 2 equals 3. 7/12 minus 3/12 equals 4/12. Is that in simplest form? Not yet. We can divide the numerator and denominator by 4. 4 divided by 4 equals 1, and 12 divided by 4 equals 3. So the final answer is 3 1/3. Training round 1 complete. On to round 2. Here we go. 4 2/3 plus 3 1/5. Do the denominators match? No, and 5 is not a multiple of 3. So let's list some multiples of each. For 3, 3, 6, 9, 12, 15, and 5, 5, 10, 15, 20, 25. What's the first multiple they share? 15. So we can rewrite both fractions with a common denominator of 15. Pause here to find equivalent fractions and finish solving in your guided notes. Since 3 times 5 equals 15, 2/3 is equivalent to 10/15. And 5 times 3 equals 15, so 1/5 is equivalent to 3/15. Now we can add 4 plus 3 equals 7, and 10/15 plus 3/15 equals 13/15. Do we need to convert or regroup? Nope, it's already a proper mixed number. Is it in simplest form? Yeah, not every problem requires regrouping or simplifying. Up next, 8 1/6 minus 3 11/12. What do we need first? Common denominators. 12 is a multiple of 6, so we can rewrite 1/6 as 2/12. Now we have 8 2/12 minus 3 11/12. Wait, 2/12? That's not enough to subtract 11/12 from. Oh, another training tip. When the fraction is smaller than what you're subtracting, regroup one whole to get more fractional parts. Let's give it a try. We can regroup one whole from the 8 we have, which leaves us with 7. How many 12ths are equal to one whole? 12 12ths. We combine that with the 2 12ths we already have, and now we have 14 12ths. That means 8 2/12 has the same value as 7 14 12ths. It's just grouped a different way. And now we can subtract. Pause to solve in your guided notes. Seven minus 3 equals 4, and 14/12 minus 11/12 equals 3/12. Can we simplify? Yes, we can divide by 3. 3 divided by 3 equals 1, and 12 divided by 3 equals 4. So our final answer is 4 1/4. Training rounds complete. Nice work. Your challenge still awaits. It's time to earn your adding and subtracting mixed numbers badge. Solve each problem. Record your answers in simplest form. 3 1/2 plus 2 7/10. 6 1/4 minus 3 5/8. Pause here to use what you've learned to complete the challenge. To solve 3 and 1/2 plus 2 and 7/10, first, we need to find common denominators. Fortunately, 10 is a multiple of 2. 2 times 5 equals 10, and 1 times 5 equals 5. So 3 and 1/2 is equivalent to 3 and 5/10. Now we can add. 3 plus 2 equals 5, and 5/10 plus 7/10 equals 12/10. What do you notice about our answer? It has an improper fraction, so we can convert that to the mixed number 1 and 2/10. Then we regroup that 1 whole with the 5 we have, equaling a total of 6 and 2/10. Is our answer in simplest form? Not yet. We can simplify by dividing the numerator and denominator by 2, which gives us 1/5. So our final answer is 6 and 1/5. We need to find common denominators for the subtraction problem too. 8 is a multiple of 4, so we can multiply by 2. 1/4 is equivalent to 2/8, but we need to subtract 5/8. How can we get more eighths? Regroup. 6 and 2/8 can be regrouped as 5 and 10/8. 5 minus 3 equals 2, and 10/8 minus 5/8 equals 5/8. Is that in simplest form? Yup. So our final answer is 2 and 5/8. Great work! So, what have we learned today? We learned that when adding or subtracting mixed numbers, the denominators must be the same so that we're working with pieces that are the same size. When an answer includes an improper fraction, we can convert the fraction to a mixed number and regroup the answer as a proper mixed number. We also learned that if the fraction is smaller than what we're subtracting, we can regroup 1 whole to get more fractional parts. And we know that answers should be recorded in simplest form so they're easier to understand. All right! You've earned the Adding and Subtracting Mixed Numbers badge, but your training isn't over just yet. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with fractions greater than 1. And remember, Math Masters, in math, as in training, progress comes with patience and practice. I'll see you next time.
Hey, hey.